Here we are going to discuss about Greibach normal forms. So before moving to Greibach normal form, we should know why we go for Greibach normal form. So the Greibach normal form will help to recognize language, and also it is help to parsing algorithms and compiler design, right? So Greibach normal form, a context-free grammar is said to be in Greibach normal form if all productions are in the following form. So the start symbol should contain, or it may contain, epsilon, so that we call it as S tends to epsilon. A non-terminal generating a terminal, that means non-terminal generates a single terminal, and the another rule is the non-terminal generates single terminal followed by any number of non-terminals. Okay, so these are all the three rules we have to follow while converting CFG to GNF. That means context-free grammar to Greibach normal form. The first rule is the starting symbol may contain epsilon. Next, non-terminal tends to single terminal, or non-terminal tends to single terminal followed by any number of non-terminals. So these three rules we have to follow. So consider here we have two grammars G1 and G2. We are going to find out which one is GNF. So here consider S tends to A, the single terminal followed by non-terminals, right? So likewise we have A and B. So this satisfies our rule. So G1 is the GNF. So the second one, C, G2, S tends to A, that is terminal followed by any number of non-terminal. The S also satisfies the condition, A satisfy the condition, and B satisfy the condition. And here C, we have epsilon for A, right? So according to the rule, we have to we should have epsilon only for the starting symbol, right? So here we have epsilon for A and B. So it is not applicable in GNF. So G2 is not in GNF. So here G1 is GNF and G2 is not in GNF. So here we see the difference of grammar, how it has GNF, right? So next, we are going to convert it into GNF form. First, you will be given a context-free grammar and you have to check whether it is in CNF. So CNF you know, right? So CNF is Chomsky normal form, right? So once the CFG is given, you have to check whether it is in CNF. If it is not in CNF, you have to convert it into CNF. That is the first step. The next step is you have to change all the non-terminals name into sequential order. That means A1 till AN. So let's see how to name the variables. So here the given is CNF, right? So S tends to XA, non-terminal tends to non-terminal, and also non-terminal tends to non-terminal. So what is the rule of CNF, the Chomsky normal form? It should have non-terminal and it generates non-terminal and non-terminal, or it generates non-terminal tends to terminal, right? So the given grammar is CNF, and you while for the first step is the given grammar should be in CNF, right? So the given is CNF. So the next thing is you have to name from 1 to N. So I am naming the variable S to A1 and X to A2 and B A2 A3 and B A4. Likewise, I am naming the variables, that is non-terminals I am naming. Now the updated CNF will be A1 tends to A2 A3. Here I am naming all the variables in ascending order. That's all, right? So after naming the variables, the CNF will becomes like this, right? So what is the next step? check for every production rule if right hand side has first symbol as non-terminal. Yes, the right hand side first symbol non-terminal, say AJ. So in the right hand side, so consider that you have A tends to A1 tends to A2, like you have the production, okay, A2, A3. So which one is the right side? So this one is the right side, right? So the right side, we say that it is AJ, okay? And left side, we say that it is AI. What is the condition? I should less than J. So I value should less than J. So what is I value? 1. 1 should less than this value 2. So if it is so, if the grammar is correct. Otherwise, what we should do? I greater than J in the sense, we have to replace AJ at its place in AI. We will see how to replace it. Okay. If I equal to J, it is called left recursion. So if I and J value, that means left hand side I value and right hand side J value, if both are same means that we call it as left recursion. So we have to create a new state Z. You have to introduce new state Z, which has the symbol of the left recursive productions, once followed by Z and once without Z. So we will see this example how to remove this left recursion by introducing the new state Z, right? So see here, eliminate direct left recursion. So how to eliminate the left recursion? So here consider we have left side A and right side A, right? So both are same symbol. So you have to introduce a new symbol Z to remove this left recursion. If left and right side both are same means that we call it as direct left recursion. Okay. So you have to remove that. So how can you remove that? So you have to introduce a variable Z. So see, after this first symbol, what are all the variables present? You have to add it with Z. So see here, after A, we have B, right? So you have to add B after Z. So B, and also you have to write B as it is, and you have to add Z. Okay. So likewise A, what are all the remaining terms B, A and A? You have to write B, A and A as it is, and also add Z after every productions. B, A, after BA, you have to add Z. After A, you have to add Z. Then B comes as it is because B doesn't contain any left recursion, right? So B comes as it is. So here we introduce variable Z because A and A both are same. That means it is left recursion. So you have to remove that left recursion. For removing that, you are introducing the variable Z. Okay. So after A, what are all the variables you are having? You have to write that as it is and you have to write it with Z. Okay. Likewise, we have written here. So, and I am also giving another example, that is eliminate direct left recursion. So, some more example to make familiar with how to remove left recursion, right? So, consider here you have A, capital A and A. That means non-terminal and single terminal. So, this is left recursion, right? So, because A and A both are same. So, you have to introduce Z of the variable A right as it is and A Z. Okay. Then what for A we have another production B. So B right as it is and you have to introduce Z in here. So removal of left direct recursion, you have to introduce the Z variable and you have to remove the left recursion. Okay. So this is the example how to remove the left recursion. So we have see the three steps. The first step is the grammar should be in CNF. The second step is you have to name the variable 1 to till n, and you have to check I and j, that is left side and right side. And if left side and right side both are same, that we call it as left recursion. You have to remove the left recursion that we see, right? The fourth step is replace very first non-terminal symbol in any production rule with its production until production rule satisfies the condition. So what is our condition? The condition is non-terminal tends to single terminal, and the non-terminal tends to terminal followed by any number of non-terminal, right? So after doing all the three steps, you have to check whether our GNF is in the following condition form. That is our fourth step. Okay. So we will see one example. So consider that you will be provided the given grammar. Okay. And the first, the grammar named we are in the second step, right? We named the grammar. The next step is we have to check, right? So what we have to check, the I value and the j value we have to check. So check here, this is I, right? This is j. I less than j. If the condition met, that is no problem. If the condition not met, we have to substitute and we have to see whether the left recursion occurs or not, right? So I less than j. Here the condition satisfied. Okay. 1, 4. So 1 less than 4, right? So the condition is true. The next you check 4, and here it is not a non-terminal. So we cannot check, right? The checking of I less than j will be happen only for the non-terminals. Okay. Here 4 and 1. So that means 4 greater than 1. So at that time you have to substitute the value for this A1. So what is the value for the A1? A2, A3 and A4, A4. You have to substitute that. Okay. So that I have shown here. For this A1, I am going to substitute what? A2, A3, okay. And also A4, A4. So my A4 becomes, so already A4 has already B. So B, then A2, A3, A4, 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 right? So now check 4 and 2, okay. So again, yeah, 4 greater than 2. So what I have to substitute for A2? I can substitute B, right? So here instead of A2, I can substitute B. So my grammar will become A4 tends to B, A3, A4, right? So, and check here A4 and A4. That means left recursion occurs. So for occurring left recursion, what we have to do? We have to introduce the symbol Z, right? So I have introduced the symbol Z, okay. See here left recursion occur, okay. So I am introducing for which variable the left recursion occurs. I have pointed out here, okay. So I am introducing B, A3, A4, Z, B, Z, okay. Then remaining A4, A4, I am writing Z, A4, A4 and also A4, A4, Z, okay. That we discussed previously, right? So we have seen 2 examples and I also discussed how to remove the left recursion, right? With the help of that, here we used the new state Z for left recursion, okay? Now my grammar will become A1 has the following productions and A4 has the following productions and Z has the following productions, A2, A3, okay. And I am check whether all are meet out my conditions, Greibach normal form conditions. So what is the condition? Non-terminal tends to terminal and non-terminal generates terminal followed by any number of terminals, right? So this satisfies the rule, this satisfies, this satisfies, this satisfies, and here A1 and Z not satisfied, right? So here I am going to substitute the values. Instead of A4, I can substitute these all things, right? And also this instead of A4, I can substitute these all things. So it becomes GNF, right? So and also for A2, I can substitute B. For A4, I can substitute this all those things, right? Yes or no, right? So now my grammar becomes C. So I am substituting for every variable. I'm substituting the values, okay? For Z, A4. So the A4 value is here. So I'm substituting all the values instead of this first A4, okay? Why I am substituting only for the first A4? Because the first one should be the terminal and followed by any number of non-terminal, right? So I am substituting A4 values in this Z for making it is in GNF form, okay? See here, likewise A1 and Z will be in GNF form, okay? Finally, all my productions, all my grammar in Greibach normal form, right? Check here. So what is our condition? Our condition for GNF is non-terminal tends to terminal and non-terminal tends to terminal followed by any number of non-terminals, right? So after substituting all the values, we'll be getting finally the GNF form. So this is all about converting CFG to GNF. Thank you.